Well, I'm going to go ahead and kind of talk a little bit about the agenda for today, and I'm also going to go a little bit slower today. I know last time I kind of made you guys splash into the deep end and get going with Revit, but I also covered a lot of material, and I know I've probably confused a few of you in the process, but what I'd like to do today is really, since at the end of last workshop, we basically kind of brought up the idea of you guys were actually working in the massing environment and kind of coming up with your overall form for your buildings, and you're kind of working in that, what I call the conceptual design environment within Revit. The conceptual design environment within Revit is working in a massing environment, but there's also a couple other families that we can work in that also act in a similar way that allow us to do detailing and other types of tectonic structures on complex forms. So a lot of, the earlier question was, what is massing, what is it best used for? It's mainly great for your overall form finding, kind of playing around with. We talked about intuitive massing at the end of last workshop. But I also want to get into where we could actually program these masses to be a little more parametric so that you can actually have true dimensions to them. Whereas when you're doing the intuitive massing, you're kind of pushing and pulling things, but everything's kind of a relative scale. You're not really typing in, actual dimensions here and there. Whereas when we start applying parametric capabilities to our masses, we can, make one mass, but then we can also make it turn into different components. So I want to kind of go over some strategies for just working with like a twisty tower kind of down there at the bottom left. But at the same time, how we can then host a couple points to the twisty tower so that you can then offset a skin. I know a lot of you were talking about peeling away skins from the facade and doing all those type of things. And I had a lot of questions throughout between last workshop and now about those type of forms. So kind of give a little strategy of how to work with that. And then I just want to also touch base. We won't necessarily make all of those things that you see up there, but I want to touch base on how you could work with a curtain panel pattern-based family, which is this repeated element that you can actually apply across a mass. You can divide a mass into various configurations and then make one component and really make it array across the whole entire surface. And then as you move the mass, this particular form is always going to move with it. The other component is an adaptive component. So we can make kind of this free-form component that could also repeat over a surface or even just be something that we use as a more efficient way of modeling. I also wanted to cover getting into a little bit of some of the tectonic details in the project environment. We touched base a little bit about parametric families last time. It was real basic. We made that rectangle and never really went back to it. So I actually want to use that parametric rectangle and use it for a reveal and some sweeps on a wall system. And then since you've got a presentation coming up, I was also going to show some very basic ways of representing your work out of Revit. So basically how to make floor plans, how to make sections, elevations, how to put them on a piece of paper, print them. I know a lot of these computers don't have print to PDF, so we'll have to work through that because I have that on my computer, so I have to see what you guys actually have here. But then also talking about maybe some very basic rendering techniques if we can get to that. If not, I have some tutorials that I can throw your guys' way that you guys can view about rendering so that you can get some very basic representation for your upcoming midterm project that you've got. When is this going to be?
Next Friday.
Next Friday? Okay. So, and then I'll also try to cover one of the main things, or one of the questions that was just asked was about how Revit doesn't have layers like you're used to in AutoCAD, SketchUp, Rhino, and all these other programs. And speaking of other programs, one last thing I wanted to do at the very beginning is also talk to you about how you can bring in SketchUp and Rhino components into Revit and then allow Revit to sort of transform them to make a Revit object. So we'll cover that at the very beginning. But if everyone can just open up, I'm just going to kind of close out of these projects I've got open. Go ahead and open up Revit. And let's get to that splash screen. So you should be able to kind of have this view on your screen. And for right now, let's just open up an architectural template. Now I want to talk about why there's no layers within Revit. once you open up Revit, if you can type in VG on your keyboard, V as in Victor, G as in girl. They don't have to be at the same time. You can just do them one at a time. This brings up what's called your visibility graphics. You can also get to this in any view. If you look over to the left, if I'm in like a floor plan view, you can see there's this option here called visibility graphics. You can click that edit button, and that also brings up your visibility dialog box. You'll kind of scroll down and you'll see that we've got model categories and annotation categories and some other imported and so on. But if you scroll down, you'll kind of see that there are what's called categories in Revit. So there are no layers, but everything that you draw, no matter what you do, automatically gets put on a particular category. So some of these are very self-explanatory. You can see ceilings, scroll down, you can see walls, windows, doors, things like that. So as you start to draw a wall, it automatically goes onto a wall category. So if you want to turn off your walls, you can go into the visibility graphics and you just uncheck that particular category, and all of those components would go away within this particular view. Now, it's very similar to layers. You can turn off and on layers, but as you know, in AutoCAD and other programs, layers are more customized, where you can name them whatever you want. And you can, everyone's got their own naming standard and everyone does their own thing. So Revit has decided to make it so that everyone, no matter what you draw, is always going to be on kind of the same, in quotes, layer. So when you draw a wall, it's always on the wall category. You can't change that around. So anyway, and this also working in categories allows you to schedule components correctly. So when you get into scheduling, which we kind of did at the end of last class where we did those mass floors, that's because mass floors are on a mass floor category. So the categories are very important, and that eventually gets into further bits and pieces in Revit where you can start to really not only schedule, but you can also turn things on and off, and then also change your visibility. And those visibility graphics are view specific, so if I turn off something in level 1, it's going to be on in level 2 until I go into level 2 and do the same thing, type in VG and turn those on and off. And I'll get into some of the program components later, probably in another workshop. So for right now, what I wanted to do is talk about these other modeling components such as SketchUp and Rhino, because I know a lot of people are using those. If you can go to, and hopefully this works this time, I remember last time you guys had some trouble, but jrodesign.com/downloads, and I've got this folder here at the very top. If you just click into that, I've supplied you with some various types of test models that you can download. Essentially, the strategy if you're trying to import anything from another basically 3D model program, Revit works really well with DWG files. Even though it says it can import SketchUp files and SAT files, which are solid files, it doesn't always come in as well as if you were to just go into Rhino or SketchUp and take your model and just export it as a DWG. So everyone hopefully knows how to do that in Rhino and SketchUp, but if you export it as a DWG, you're able to easily bring it into Revit and we can utilize it in some manner. If you can get to this website, again, it's jrodesign.com/downloads, and then I've got this folder that's up at the top called CSWS02, little code there for Comprehensive Studio Workshop number 2. And if you can, just go ahead and download. I've got a couple different DWGs, but you can do the Rhino to Revit test. I'm going to right click on that. I'm in Internet Explorer and I'm going to save target as and just save this somewhere that we can actually access it. I'm also going to download the SketchUp to Revit DWG just as another example. So I basically have a Rhino file that I did a little bit of very basic modeling in it, and I did an export to DWG, and then I've got the same thing that I did in SketchUp. They're not that fancy, but we can utilize them. So up at that folder right there, if you click on, double left click, yep. So I'm going to just kind of go into an architectural template. And if you're bringing in any kind of imports from DWGs and you actually want to use them as like a base underlay, we actually have to bring them in as a mass element. So we, at the very end of the last class, we started talking about intuitive massing. And if you remember, we went to the Massing and Site tab. And if you go to In Place Mass, we just want to create a new mass. And I'll just call it Mass 1 for now. And this is where you would bring in whatever import that you would like. So once you're in this In Place Mass, you can go to Insert at the very top. And here we can import a CAD file or we can link it. We actually want to import because importing it will allow Revit to sense the different parts and pieces of the file, and then we can eventually attach some walls and or floors or roofs to it. So if you go to Import CAD, you want to browse to wherever you downloaded those files. And I've got the Rhino to Revit test I'm going to do first. So we can go ahead and just click on that. We can just keep all the other additional settings that are down at the bottom and then just go ahead and click Open. If we look at this in 3D, so click on View, Default 3D, I basically just have kind of this NURB paper form. And it's actually, when I was modeling this in Rhino, I was in inches. So I actually need to scale this up. If you're going to be actually bringing things in from other files, Revit, its global unit is the foot. So it's, basically you want to make sure that all your Rhino files are already in the feet to inches units instead of working just in inches. So, but because this came in at a smaller scale, before I can use it, I'm going to select this component. So you can just highlight it. And there's a little scale command up here under Modify, up at the very top. And in your options bar, this is where you can set a numeric scale. I'm just going to scale this up by 12. So if you click on numerical and then type in 12, and then you just want to snap somewhere, into the actual space, and that will kind of, scale that up appropriately. So here's a kind of a complex form, obviously not too complex, but it's not a straight form by any means. It's just a NURB form that's been lofted together in Revit, in Rhino. And what we can do is once you've imported that, you can go ahead and click on Finish Mass. There's a little checkbox up there. And once you finish the mass, we can now use this as an underlay. Remember we kind of talked about some modeling of complex forms where we tilted a wall. And basically then we applied a wall to that mass form. This is basically your mass underlay. If you don't see those checkboxes, you probably have a little tab up at the top that's green. If you just click on that, you can get the finish mass. So because this is a horizontal surface, I'm going to make this into like a roof form. So we can go back into our massing and site, and there's an option here to place basically a roof by a mass. So if we click on that, we can choose whatever form, basic roof that we have available in Revit. And I can click on that and then select my underlay, sort of that, the Rhino file. And once you've selected it, at the very top here, there's an option here to create the roof. So once you're done, you can click on that, and it will create an actual Revit component that was tied to the mass form. Now you'll see this kind of checkerboard pattern. That's because we've got a mass form right on top of a Revit form. And eventually we can just turn off the mass. So if you go to Massing and Site, there's this little Show Mass Form and Floors. If you click on that, actually that didn't work, we can type in VG, and we have a mass category we can turn off, and click OK, and that will take that away. So now this is a true Revit element that is actually referencing a Revit component instead of just being some kind of component out of another file. We can do the same thing with a SketchUp file. So if we again go to Massing and Site, I'm going to create another mass. So I'll go In Place Mass, and I'll make a mask number 2, and we can go ahead and import. So go to Insert, Import CAD, and then I'm going to scroll down to find the other file here called SketchUp to Revit. And again, we can just hit Open. And that one was some other larger scale, but basically it's kind of this simple wall that was done in SketchUp with an opening. But again, we can use that as an underlay. I can click Finish Mask, and then we can go back to our massing and site, and this time, since it's a wall, we could use the wall option for wall by face, and I can go ahead and pick whatever wall type I want. I'll just pick the generic 8-inch, and then I can pick, if you kind of hover over the face of the component, it'll now apply that Revit component to this SketchUp model. And again, I've got my mask turned off, and I'm going to also turn it off over here. Now the only downside to working this way, and I can actually edit these once I'm done, but sometimes if you want to make a more complex, so for instance the kind of paper form that's down here at the bottom, if I wanted to change that overall form, the only downside to this method is I'd have to go back to Rhino, make the change, and then do the re-import, and then apply this, kind of go through these steps over and over again for every little change that I do. So there are kind of some limitations to that, but as a means of getting you started from going from a SketchUp or a Rhino into Revit, this could be a way to start to do that as an underlay. Any questions on that? That's all I really want to cover on those type of components. I want to get into the massing. Now at the end of last class, we got into intuitive massing, and we did it in the project environment. So just like we just brought in these SketchUp files and also the Rhino file, all of this was done under massing and site. One thing I want to note is if we go to our view, so click on View at the very top, I'm going to go to User Interface off to the far right, and I'm going to select Recent Files. This will bring us back to this splash screen without closing out that project environment. If you were to take the intuitive massing environment out of the project environment, so basically when we were in this project environment and we clicked on massing and we went into In-Place Mass, remember at the very top, notice the toolbars at the very top. When I go into that massing mode, we get a different set of tools, and we also have other ways of working, but we don't have all the different tools that were part of the project environment. That's because once you go into this mode, you're actually going into a massing family that's kind of built into the project environment. So what I like to do is actually model in the massing family and then eventually bring those masses into the project environment, because we can then place them as objects and then sort of work with them a little bit easier. And then we also have the ability to work with these curtain panel pattern-based families and adaptive components. So I'm going to delete the stuff that was part of the project environment. I'm going to close out of this project environment. And again, if we were to go into, if we extracted that massing environment into its own family, if you look down at the bottom here on your recent files, under Family, there's this option here called New Conceptual Mass. If we click on that and then choose the mass template, they only give you one option there, but go ahead and click Open, you'll notice that the tools that are at the very top are very similar to what it was when you were actually in that project environment and you were clicking around once you're in the massing environment. The only difference is, the background is just kind of this gray gradient color. That's basically the only difference. So everything that you do in the massing component part of the project environment, you can do here. And if anyone's used Vasari in other classes, I remember not a lot of you have used that yet, but basically Vasari is also the same exact environment. So what I'd like to do is we can go ahead and just do a quick little recap on the intuitive massing. I'm not going to spend a lot of time on it. But here in this environment, I can just go ahead and draw a rectangle and I'm going to take this rectangle and we can extrude it up. So you can remember, you guys have probably been already doing this, but hit extrude solid form, and then we can kind of push and pull these different parts and pieces. And if you remember, you can tab over different parts of the form, and we can kind of do that intuitive massing where we are just kind of eyeballing these things and kind of getting a general form. But because this is its own family component, what I want to do is think of this as a AutoCAD block or like a Rhino block, or if you're using SketchUp, you're probably used to using components. This is the same idea. They're just called families here in Revit. So I'm going to save this as a separate file. I'm going to say that this was all I'm going to do to this particular form. I'm going to go ahead and do a save as, and of course we can save it as a family. Let's save it somewhere. Let's just call this mass tower number 1. I'm going to make a couple more adjustments to this. I'm just going to kind of modify. This form in a little bit of an intuitive manner, just to make it a little bit different. And I'm also going to save this one, so I'll do a file save as, and let's just call this mass tower number 2. So basically, for every little component that you make, you can make them as separate, volumes. So if you were, working with, whatever your scheme might be, you could have different volumes. You could make different blocks, kind of like these kiddo parts, in these family environment. And what we can do is go back into a project environment. So if we go to View, User Interface, Recent Files, I'm going to open up an architectural template. And we can click on Insert, and here we can load. There's this option here to load families. So you could make as many of these blocks as you wanted to. We could click on Load Family, and then we could go ahead and browse to wherever you were saving these. And I can actually hold in the Control key and select multiple components to basically insert into my project environment. And I can go ahead and click Open. What this will do is it loaded those families into our project browser. I can go to Families, I'll look under Mass, and I should see my Mass Tower 1 and Tower 2 are located there. So what that means is I can go to an Architecture tab, and if we click on Component, you should see in the far left you have the ability to choose Mass Tower 1 and Mass Tower 2. So I'm going to place Mass Tower 1, and I get this little warning that we can't see anything, and that's because under Massing and Site we also have to turn on our masses, so that little pie. And then I'm also going to go back to Architecture, Component, and I'm going to choose Mass Tower number 2, and of course I could place multiple of these. These kind of act as, AutoCAD blocks or Rhino blocks. I can also rotate them, so I can click on them, just rotate them into place, however I'd like them to be. And now if we look at this in 3D, so I go to View, in a default 3D view, you now kind of have all these components that are part of this project environment. So that's one way of kind of working. You can actually make all these components and then place them however you'd like, instead of trying to model everything in that individual conceptual mass environment that was part of just massing and site. It tends to make it a little bit easier to sort of work with, I think. And by working in the conceptual mass environment, so I'm going to actually delete those. If we close out of that, and if we go back into this massing environment, we can do a couple other component, or we can really work with a couple items here where we could start to kind of make these things more parametric and actually have dimensions to them, so that we're not just doing these intuitive massing components. And I'll get into how to cut voids into them and do other things once we place them into the other environment.
Any questions about the family environment so far? Yes.
How do you see them? I missed that part.
Yeah, so when you bring them in, one thing that is a little bit, I kind of consider a little bit frustrating when you're in the architectural project environment is that by default, under massing and site, your masses are always turned off. So you see this little pie icon. If you just click that on, that should reveal your masses in whatever view you might be in. If that doesn't work, sometimes you have to go into your visibility graphics, so that VG that we started with, and you can also click on the category for mass, and that will show your masses. The reason why Revit always kind of hides those is it assumes that you were using that as some kind of underlay for your base, geometry, to apply like a wall or a floor, and it just by default always wants to turn them off. That's going to be important because when you start to do renderings or try to represent this on a piece of paper, you'll kind of load up your project and you'll see that all your masses have disappeared, and it's just because they've been turned off. Every time you kind of load up Revit, it tends to turn them off by default.
One question.
Yeah.
Once you bring these families in, if I change those families outside the project browser, would they automatically change them in the project or not?
Yeah, so the way that these components work, that's actually a good question. Let me load up, since I closed out of that. I'm going to place those families one more time. So I've got my mass tower 1, and again, you can place as many of these as you want. I'm just going to place a couple of the mass tower 2. Look at that in 3D. And because these are considered components, just like you might be used to with SketchUp or even in Rhino with blocks, if I click on one of these components, so this is my mass tower number 1, if you look at the very top, when you click on something, it gives you the option here to edit your family. So if I click on that, it's actually going to load up the family in its conceptual design environment. And if I go into my 3D view that's in brackets, let's say I want to make a change to this particular family. If I kind of manipulate it a little bit.
Can I ask real quick, how did you get back to the family from the project?
Yep.
I just missed that sequence of.
Sure. So back here in the project environment, at any time if you click on a family that's placed, you'll always get this option up here to edit the family.
Okay.
And when you click on that, it'll take you back into that world.
Thanks.
Also, you can you'll notice a lot of times what I'm doing is at the very top, because we've got all these project environment and we have family components kind of open at the same time, Revit at the very top in your quick access toolbar, that's kind of what that top line is called. There's this section here that looks like a couple different windows at the very end. If you click on that, that allows you to switch into different views that are already open. So I've got my project that's open, and here's my mass tower number 1. So if I click on that, it switches me into that view. So I made some updates to that family component, and if I save it, so I'll go ahead and save it and overwrite the file. There's this option here called Load into Project. So at the very top here, if you're in this environment, once you've done any kind of changes you want, and if you also have a project that's open in the background, we click on Load into Project, and I want to pick my project number 6. That was I haven't named that file. That'll bring it into this project environment, and I can go ahead and just overwrite the existing, and everywhere that number where that mass tower number 1 was placed is going to update. So that's a good way to sort of place this on your topography surface. If you guys have a site, you could have all these components already placed, and then if you need to sit there and make edits, I like to generally go into each individual component in mass form and make those edits instead of having all of them together. It kind of starts to make it a little bit easier to work with and starts to make it more manageable where you can really study that particular part of the form and then make your updates and add your complex geometries to it eventually. Yes?
When you went to edit that mass, well, I went to edit the mass by hitting Edit Family, and it opened the window, but I can't do anything.
So, so you'll notice that when I clicked on Edit Family, I've got this kind of view here. One thing that is a little bit, that happens all the time, it seems to default to this 3D view number 1. If you go to the other 3D view, you can then manipulate it. I usually tend to eventually just delete that 3D view 1. It seems to be some kind of setup perspective that you can't edit in. I'm not sure why it's there, to be honest. So now I want to talk about a little bit, we did the intuitive massing and we kind of covered that in the first workshop at the end. I want to talk a little bit about making these a little more complex and also parametric, and start talking a little bit about parameters. Again, we touched base a lot about the concepts of parameters in last workshop. This would be a good way to start working with how to make these forms parametric, and also give you abilities to make one component. I could actually make this one mass, but make it do 3 different things eventually. I'm going to close out of all of these files because I don't really need them at the moment. I keep going to the applications menu, that's the big R, and then I click on close, and eventually I close out of all of those. I'm going to click on new conceptual mass. Again, we have to select that template, and we're back in that environment. If we look at a north elevation, so in your project browser, double click on north. You notice that in this environment we only have one level. So remember, we talked a little bit about floor levels and datums last time. These levels are just basically considered work planes when you're in this environment. So instead of thinking of these as floors, I'm going to actually just call this, I'm going to click in level number 1, and I'm going to type in bottom. I'm going to call that bottom, and I'm going to also tell it to, it says, would you like to rename all the corresponding views? I'm going to go ahead and click on yes. I'm going to create another datum, and this will be the top. So if you go to create, you have this option here to make a level off to the far right. Now I'm just going to draw a horizontal datum somewhere above the other datum. And all I did was draw, point and click one side to the other. And this one automatically comes in and is called level 2. I'm going to call this top. So again, I'm just thinking of these as work planes, and what that means is when I click on my floor plans, and if I click on the bottom or if I click on the top, I will be drawing on those particular work planes. So I'm going to, in the north elevation, I'm going to make a dimension from one datum to the other. So if you click on, if you're in like a modify tab, you can also find dimensions under create. I'm using the aligned dimension. It's kind of the dimension string I always use. And we can click on each of the datums, and I'm just going to click on both. And then when you're done, it wants you to click kind of somewhere off into space. I'm trying to place it, and I'll just click so that I have a dimension going from the top to the bottom, or the bottom to the top. Now I'm going to make that dimension actually a parameter so that I can eventually change the height of this particular tower. So I'm going to have bottom and top, and eventually I want to change all of these components and have them have different heights. If I'm in the Modify tab or the Create tab, you see this icon here. It's if you hover over it, it's called Family Types. It's kind of the, I guess, the third box over, or the second box on the bottom. Go ahead and click on that, and you should get a dialog box that pops up that's basically blank. This is basically an Excel spreadsheet where we can add parameters. And parameters can be whatever we want them to be. We can name them whatever we want. And if we click on parameters where it says add, I'm going to show you down here where it says type of parameter. These are all the different parameter types that you can have. So a parameter can be a text, integer, number, length, area, and the list goes on. We're just going to deal with length for now in everything that we do, and maybe get into angle rotation. So I'm going to click on, we'll keep that type of parameter, set the length. And the name of this, I'm just going to call it H. I'm going to call it H for height. You could type in height if you want, or whatever else you would like to call this particular parameter. So once I click on that, it basically enters in a parameter into this spreadsheet, and then I can click OK. To make something parametric, if we select the dimension string, up here in the options bar, you'll see this pull-down menu called Label. You should be able to find your parameter that you just created called H. All that does is it turns your dimension where it now says H equals and whatever your dimension happened to be. What that means is in this Family Types dialog box, so if I go back to that, I can now change this number. So right now mine happens to say 128 feet. I could change this to 200 feet and click OK, and it's going to move my top, and that dimension is now going to equal 200 feet. So now we've just made something that will start to stretch depending on what we eventually type in. So you could actually be more specific about your tower heights or whatever building you're starting to design. I could actually give it an actual dimension and then know that my tower from bottom to top is going to equal that. While we're here, I'm going to go to File and Save As, and we're going to save this as a family. And let's call this Twisty Tower. Just call it Twisty Tower. Now what I'm going to do is make a couple more parametric components, but I'm just going to do this on the bottom floor plan. So if we go to bottom, while we're in this massing environment, one of the nice things is we have this point element that doesn't occur in any other part of Revit. And this point element, if we click on it, I'm just going to place a point somewhere in the center. This point element is actually a reference plane. It's actually a point that has 3 different reference planes that are associated with it. And what's nice about it is this point also has parameters that are already built into it. So we've got a rotation angle and then also an offset. I'm going to keep that at everything where it is. But when I select that point, if you look to the left again, where it says Show Reference Planes, it's currently set to Never. Always by default. I'm going to set it to always, so you can click on that down arrow. And what that does is it basically turns on the reference planes. If we look at this in 3D, you should see this point, and you've got basically your horizontal reference plane and then your 2 verticals. If I click on that point, I can also change the rotation angle. So let's just test it out for a second. I'm going to change it to 45, and it should rotate with all of its planes. That'll be important when we sort of do the next couple steps. And because I drew that on the bottom floor plan, it's going to be on that bottom plane. You can notice in 3D I also have my top plane. So again, if I were to go in the top view, and I'm just going to place a point, I'll eventually delete this one, but just as an example, you can see that that point gets placed on the top plane. I'm going to delete that for now. So I'm going to look at this in 3D, and we're just going to make a simple rectangle around this point. But the most important thing we're going to do is make sure that we host this rectangle on the point itself, so that when we rotate it, everything that's basically hosted on this point will also rotate. So if we go to Create, I'm going to click on Rectangle. And before I start drawing anything, under your options bar here where it says Placement Plane, I'm going to kind of slow down here for a second. I'm going to take that drop-down menu, and there's an option here that just says Pick. So again, what I did is I went to Rectangle, and once I click on the rectangle under Create, I should have an options bar here, and where it says Placement Plane, I should be able to choose Pick. Now what it wants me to do is pick a plane, and you'll notice that when I hover over different parts of this point, it's trying to select one of those planes. I'm going to select the horizontal one. That now makes it whatever I draw from here on out is going to be on that plane. So now I can just draw my rectangle. I'm going to draw it so it crosses in all 4 quadrants. Now it doesn't matter what the size of it is at the moment because we'll eventually set some dimensions to it. Everyone get that? I'm going to go into the bottom floor plan, and I'm going to draw a couple dimensions associated with this particular point. One thing I'm going to do is I'm selecting these vertical and horizontal dashed lines, and I'm going to go over here to the eyeglasses and I'm going to hide them. The reason for that is if you happen to snap to those while we're doing these dimensions, you'll eventually get some error messages. So I just want to kind of hide those temporarily for the moment. Now all I'm going to do is make a base rectangle so that I can change it by its width and its depth. So we go back to family types. I'm going to add a parameter. One will be called W. Another one's going to be called D for depth. And we'll just click OK for now. I'm going to now take the dimensions, so back here where it says align dimensions, and I'm going to snap to each vertical. And while I'm doing this, I'm also going to snap to it's hard to see on the screen, I can't zoom in on that point, so it gets bigger, but actually I can probably do this. I'm going to make sure I'm snapping to the vertical part of the reference plane. So when you hover over it, you should see a blue line that gets highlighted. So I'm going to snap. So I'm going to do a dimension from there to that vertical and then to the other one. And after I do that, I'm going to make this equal equal. So you can click on that equality setting like we did with the offices. I'm going to do another dimension the same way. I'm going to go down. I'm going to make sure I'm snapping to the the horizontal plane of the point. And I'm also going to make those equal equal. Anyone get lost on that?
Yeah. I can't get my rectangle to stay. It just disappears.
If you start to lose your toolbars, there's this little icon here at the very top where it says Create, Insert, View, Manage, Add-ins, and so on. If you just click on that, that'll cycle through. Also, there's this Properties. If you lose your properties, there's that toggle. And you can also go to View, User Interface, and check on and off Project Browser and other parts of the interface. So if you can't get the equal to work, you've got to make sure that you're snapping to that vertical part of the point. You may have snapped to the actual point itself. Some of those things that are a little bit tricky when we're kind of working in the parametric world. So make sure you're getting that vertical. There you go. And then the next one over. So I did the same thing on the other side. And if you can't get the equal equal to work out, don't worry about it right now. Just go ahead and do the next step. And let's do another dimension. And I'm going to do an overall on each of these. Now to make sure that we haven't that we've snapped to all the right parts and pieces, if you click on your point and change your rotation angle, I'm just going to do this as a test. If I change this to 45, everything should rotate with it. If it does not, then you probably have not snapped to the right parts and pieces of that point, and you'll have to kind of go back and do that. So I'm going to put that back to 0. And I'm going to make the horizontal dimension, if I click on that, the overall. And again, if you can't get the equal equal to work, the overall is the more important part. I'm going to make that equal to W, and the other one will just be equal to D. since I have that working, I'm going to go ahead and hit save. And now this was a little bit of a lot of setup just to get this to work. But what I want to do is also have something very similar to this on the very top level that I can also change parametrically. But I don't want to have to redraw all this stuff again. So one of the ways of working in Revit, and this goes for if you're in the project environment or in any other conceptual design environment or family, if I select everything and hit copy to clipboard, so it's up here in the middle, or you can also hit Control C on your keyboard. That would do the same thing. I'll stop for a second. I'm just going to copy it to the clipboard. And also, I notice a lot of you, when you're kind of zooming in and out, you've got some very, very thick lines. And it makes it kind of hard to work sometimes, when you're trying to get real close and figure out what you're doing. If you get to the very top, there's this thin lines command that if you click on that, it just takes away all that kind of the bold line weights. So once you get that, again, if you select everything and you want to hit copy to clipboard, you also want to test to make sure that when you select that point and you rotate it, that everything does rotate. If some of you get a error message, it's probably because of the snapping issue. So what I'm going to do is go into the top view now. And this time I'm going to go to paste, but I'm going to click on the down arrow under paste. And I can click on align to current view, or I could click align to selected levels. Either one will do what I want it to do. I'm going to click on align to selected levels, and I'm going to click on top. What that does is it copies everything that we just did up to the top level, and this way we don't have to sit there and redraw and do all those things that we just ended up doing at the very bottom.
When you copy and it said the points removes that someplace?
So you probably copied it back onto itself, onto the bottom. Let's see, let me go back. So if you're in the bottom view, if you select everything, click on copy, and let's go ahead and just do paste. I'm going to go into a 3D view.
What is copy?
Copy to clipboard. As soon as I select everything, it should be in the middle. You have this clipboard section. It's the one in the middle called copy to clipboard. You could also do Control C on your keyboard, which is kind of the universal copy to clipboard. If I go into my 3D view, I can just do a paste by clicking on the down arrow, and I'm going to do align to selected levels, and if you click on top, that should bring everything to that top level. We're basically 3 steps away from the twisty tower, so we can kind of move on. Let me see what's going on. All right, so now that we have kind of a bottom and a top, one thing I want to do is make sure that my top is a little bit different from time to time, or could have the option to be different. So I'm going to create 2 more parameters. So if you go to family types again, and I'm just going to add let's call this WT for the top, and we'll do another one for D. We'll make that DT. And then you can zoom in on your top form or your wireframe, and where you've got those dimensions, go ahead and change them by clicking on each one and changing it to the new parameters that we just created. So all I'm doing there is making it so I have the option to change the 2 different types. Now I want 2 more parameters, and this will be it, so that I can actually twist and rotate those points. If you remember, each of those points had a built-in parameter for rotation. And so these parameters, when we add them, are going to be a little bit different. So when I go to add parameters, I have to click on type of parameter. I'm going to scroll down and make sure I'm entering in an angle. I'm going to call this A, B. That's for angle bottom. And I'm going to make another one called AT for angle top. And again, type parameter and angle. I'll zoom in on that a little bit here. So these are all the parameters you should have. And this will be all we make for this, this particular tower. So to get those angles, make sure when you go to parameters and add, let's see where it went, that you're picking your type of parameter needs to be set to angle. So what we can do is if you zoom in, after you've set those different parameters, if you zoom into the first one down at the bottom, if you select that point, where you guys lost at? Anybody have a question?
Yes.
Yes.
It's like the rectangle didn't snap to the point, and so when I go to rotate it, it won't.
If your rectangle wireframe is not rotating with the point, it's most likely because you missed the step where you had to place the actual point. Like when I place the rectangle, you want to make sure that you're picking the actual reference point, horizontal plane, in order for it to be associated with that point when it rotates. So the last step here is to click on each of these points. So if I click on the bottom point, you notice where it says rotation angle. You should see this button. See these buttons that are associated with each of these lines? If you click on that button, that'll allow you to make that equal to one of those parameters. So I'm going to do the AB for the bottom. And at the top, rotation angle, click on that button, and I'll make that equal to that AT parameter. You click on the point over here in the properties bar where it says rotation angle, click on that button that's off to the right, and then you can associate it with one of those parameters that you created. If you don't see those parameters, you need to make sure that when you made them, when you click on add, the type of parameter needs to be set to angle. Otherwise, since it's a rotation angle, if it doesn't know about an angle parameter, it's not going to know, it won't be able to select one. And then when you're got all of that set up, you can zoom in and you select the wireframe that's associated with sort of the bottom. And we can go to the top and hold in the control key and select that wireframe and then choose create form and your solid form. Now what we can do is click on our family types dialog box, and I'm going to play around with a couple different numbers, and we can make this form change parametrically, and we can also make within this family, we could have actually infinite number of possibilities, but we could program in other tower types within this one particular component. So what I'm going to do is, let's type in, has everyone got your dialog box open I'll let you guys catch up. 10 seconds. I'm going to go to Family Types and click on New. And right here it says Type 1. Just go ahead and click OK. What that does is it makes a new name up here at the very top. So everything now that we enter into our parameters is going to be saved to the Type 1, particular tower type. So I'm going to just make some changes here to my parameters. I'm going to make the height the H150. I'm going to change the bottom angle. Let's make that 30 degrees. And I'm going to make my tower is kind of small. It's only like 20 feet wide, so I'm going to make this a little bit bigger. Let's do a 50 by 50 on the bottom. So W is 50, D is 50. You can enter in your own values. And then up at the very top, I'm going to do something a little bit bigger so it tapers a little bit. Let's do a 60 by 60. When I'm done playing around with my parameters, if I click on Apply, that will change my tower. And it looks like my point moved here. Let's see here.
My tower doesn't seem to be twisted.
Yeah, let me see what happened here. Let me do a test real quick. Hold on one second, I'm testing something out. What I'm doing is my top form, for some reason, when I changed it, the point moved over, so my tower actually started leaning. So I'm going to back up here for a second. If you can hit Control Z before you actually formed the actual form. So just hit Control Z, that will do an undo. I need to lock my point because this top point started floating away somewhere. The bottom point, what I'm going to do, I'm going to make these back to 0. Click on the Align tool under Modify. This will solve at least my problem. Some of you may not have had this problem. But if you click on Align, I'm going to align by, I'm going to click on this dashed reference plane, and then I'm going to select the point. I got to tab over. Mine's currently locked. So I'm going to select that, and then I'm going to tab over until I select the circle part of the point. When I select that, I get this little padlock that shows up. We can go ahead and lock that. And I'm going to do that in both directions. That'll keep this point from floating away. And I'm going to do that on the bottom, and I'm also going to do it on the top. So the first thing to do when you align, you click on Align, you first select the dashed reference plane, and then we want to tab over. And then we're going to tab over and select the point itself and then lock it. If your tower was working, you probably don't have to do this, but my point sort of floated off to the side there.
Are you getting like a vertical line when you're clicking on that reference?
Yeah.
I'm only getting a lot coming out of it, so what?
Say that again.
Like I'm clicking a line and I click this line, but the lock symbol. Click this and then click this. Yeah.
Okay, everyone listen up. This is important. I actually forgot a one little checkbox here. So we've done that alignment. One thing that we have to do when we're starting to actually make solids out of kind of wireframe geometry. Right now, when you look at, if you click on your wireframe, if it's black, it's basically a black line that goes all the way around. That is called a model line, and that's what we were drawing with. Once you make a form between two model lines, it basically locks it in place to those particular components. But if you were to click on that model line, and if you look at the very left here, there's an option here to call it a reference line. So it says is reference line. If you click on the checkbox, it should change it to a purple line. It's kind of hard to distinguish up there, but on your screen, it should look purple. And also when you highlight the reference line, you'll get all these kind of dashed blue lines around it. We want to make sure that both of these wireframes are actually a reference line. The reason for that is when we make our form, it retains the wireframe and it also keeps those points there. You'll notice that when I did the first initial loft, our reference points went away, which means if you try to rotate them, nothing ever happened. So now I can select those reference lines and select them and hit my create form. So now we should be able to play around with this a little bit better. Let me catch up here. So I'm going to go back to my family types, click on new under family types and call it type 1. And I'm just going to make 3 quick little towers here. I guess it'll be kind of big. I'll do a 150 for the height. I'm just going to play around with my dimensions. Do a 50-foot base, 60-foot top. I'll make my top rotate, let's say 30 degrees. So there's the first tower type. And once you've entered in everything that you want and you hit apply, and if that's kind of the form that you'd like, basically when you hit apply, it is applying it to this name type number 1. So I can now create family type number 2 by going to family types and click on new, and it'll say type 2. And now I can change these numbers. So I'm going to change this to something else real quick. And then we'll move on. 60. So when I hit apply for type 2, it changes to whatever parameters I happen to put in there. And I'll just do one more so that we can place them into our model and then work with these a little bit more. I'll do a smaller one. You guys are doing office buildings, right? Mm-hmm. Like a little tower. Okay. Nothing as big as 150. 75 feet, 60 feet, 12 stories.
Yeah,
Okay.
could be that big.
Okay. Let's see, I'll do...
And we even have a twisty tower going.
You don't want to have those skins.
The skins are very
Is that the one
twisty.
that they picked that one?
Yeah.
Oh, it's a little squat. So anyway, after you're done doing that, I'm going to hit save. But what that does is it makes one mass that I can now change. I can use my family types and use this pull down menu, and I can click on each one and hit apply, and it's going to remember all of those settings that I just made. So basically I modeled this once, but I have as many possibilities as I want. as long as I want to keep entering in, different information. Everyone get at least, one or two different towers to work out? All right, good. So now I'm going to keep this open. I'm going to go back into View, User Interface, and Recent Files, and let's go ahead and bring this into a project environment. So we go back to our architectural template. I'm going to zoom out a little bit here. So I'm back into the project environment. I have in the background my twisty tower, so I can go back to Switch Windows, and I can click on Load into Project. Now that we've made those different types, because it was a family, and then we also created Type 1, Type 2, and Type 3, when we're placing these, you'll notice in the drop-down menu to the left, you now have Twisty Tower, and you have Type 1, 2, and 3 shown there. So obviously if you had more or less, you'd have a different number. But I can now choose which ones I'm placing. So I can pick number 1, and I can pick number 2. I can pick number 3. And once they're placed, I can do whatever I want with them.
I think I'm missing a step because I'm loading it, but don't see it.
So once you load it, you click Architecture and then place it as a component, and then you should have those menu options. And if I go to View and look at this in 3D, and now when you're in the 3D view in the project environment, you'll notice it kind of looks like what it was on our other screen. But we can actually change this background, and you don't have to do this, but I'm going to show you that under Graphic Display Options, if you're in the 3D view, if you click on it, right here where it says Graphic Display Options, Background, I'm just going to change that to Gradient. Now it makes it like our other environment. Now, if we actually want to edit these, so right now, what I mentioned before is, you always had to click on them and then click on Edit Family because they're their own components. And if you wanted to change these, you have to go back into that family environment and make your different changes. Or you can click on one, and if you look to the left, there's this option here to edit the type. And when you click on Edit Type, it brings up all of those parameters, so you could just do the edits right there without having to go all the way back. But these edits will only occur in this project environment. But that's the one nice thing about setting up parameters is now you can just sit there and make your changes right here in this environment. But let's say I wanted to cut a void through these or start to manipulate these even further based on other geometry that I already have kind of placed or I'm kind of working with within this project environment. One thing I probably should do is I'm going to Let's do a test. I'm going to have these off to the left, and then I'm going to go into Massing and Site, and this time I'm going to create a new in-place mass. And when we're in this environment, I can also go to Create and Component, and I could place my different towers. So I'm in the massing environment, and I'm basically going to place these 3 tower types again. I'm going to do a little experiment. So off to the left, these were placed outside of the massing environment. The ones that are in here, I created a new mass. I went to Massing in Place, and then I'm placing these as a component. And the reason I'm doing this is I'm going to test that, you see I have different towers that can be selected off to the left because they were placed separately. Off to the right, these are all kind of a group together. But if I wanted to do some additional edits to this mass, if I go back in, click on Edit in Place, I'm just going to draw a rectangle. I'm in the massing in place, and I can now draw some other components here. I'm going to actually create a solid form. I'm just eventually going to cut this out of these other forms. Let's see if I can.
What did you say about them acting differently than the ones that were placed individually?
So I'm going to show you in this test here that if I wanted to do additional edits to these masses once they've been placed, I kind of have to have these components as part of the massing environment. So that's why the ones off to the left were separate. They were placed outside of the massing environment, and I'm going to try to cut a void out of them. Whereas the ones off to the right, I actually placed in the massing environment, and I placed each component. I did tower 1, 2, and 3. But what that does is it allows me to do some additional modeling. So I've drawn this component here, and I can go to Modify, and there's this option here to Cut. It wants you to, down here at bottom left, it's going to tell you what it wants you to do first. It says first pick, it wants to select the solid geometry. I'm going to select the thing I want to keep, and then I'm going to cut that component out of there, and I'm going to keep going down the line. And so you can see I can start to edit these towers even though they were part of these family environments because they're in this world, and I can just hide this. Eventually right click. So I can hide that element. And you can now see that if I were to take this tower and move it, it's always going to be based on wherever that other form was. So what's nice is you could actually also have the same tower, but depending on where it falls within this particular new extrusion, you could start to cut out additional edits to it as needed. Over here, I can't select that. If I were to finish the mass, let's do a test here. I don't think I get I do have the cut option. So actually, it does work on both.
Can you go over that cutting meter step again? That seems really useful.
So in order to cut geometry, and yes, it is actually pretty nice. One thing that's hard to work with within the conceptual mass environment is the void. You draw the void, and then eventually it goes away, and you have to somehow find it to edit that particular object. The other way of working is you could actually make a solid element. So what I did is I made, in the massing environment, I think everyone saw that, where I just made a rectangle and extruded that up as a solid. Once it's a solid, we can now use this cut option, which is under Modify. So under Geometry, there's Cut and Join. Kind of works as your Boolean unions and Boolean difference, kind of like in Rhino. You can click on Cut, and what it wants you to do is first select the object you want to basically keep. And so I'm going to select this first tower, and then the cutting object is the next one, so I can click on that. So you should see it cuts out a little void there, and I can go ahead and do that on each tower, or I could skip if I wanted to. You could probably even take another tower and cut it out of another tower and do all those type of things. So if you wanted like a void in the middle, you could have like a smaller twisty tower in the center, and if you were to kind of double those up on one another, you could cut one out of the other, and you'd end up with a kind of like an atrium space in the middle.
Hey, Jeremy?
Yep.
Maybe to your point, the ones that are created individually,
Yep.
I think if you if you slide that around, and maybe move it all the way into the other object on the other side.
Oh. Yeah, like would it cut?
Yeah, because all the
Yeah.
Yeah. So because those were all grouped as a mass, those are now all cutting through. They're all assigned to cut that object, right?
Right. So because I modeled all of these extrusions that are rectangular plus all of those towers as one mass element, they were called mass number 1. And because I chose to cut mass number 1 out of this tower, no matter where this goes, it's going to also, intersect with those towers and also get cut out. So if I wanted different components being cut out of these towers, I could create like mass number 1, and then I could do another mass. I could do mass number 2 and do something different, and I could start to put those together. So that might, give you a lot more flexibility with your modeling if you start to think about these as individual components, and then these kind of solid geometries that you can cut one another, and it starts to make some pretty nice opportunities. Now, one thing I wanted to mention is, I think if I go into Edit Mass, I can eventually delete, let's say I'm done with that solid. Nope. I kept it over here. That's interesting. You have to kind of play around. So it looks like I have to keep those elements there. So the other part about this is that once you've kind of done all of your different joining, you can also join these components together. Instead of cutting, I could have just click on join, and I could, let me actually make another tower over here. If I were to kind of click these two together or make them overlap, instead of cutting, I could also join solid geometry. Basically, those kind of, whichever one you selected first has priority, but it becomes kind of this one component that's joined together. Kind of looks the same, actually, but the one point I wanted to make is that because I've got these separate towers, and then I also have these towers that were part of a mass by itself. When we start doing mass floors, one of the questions earlier at the very beginning was, how could you differentiate? Let's say you have different volumes, for instance, and different volumes want to have different floors. Maybe they don't always want to have level 1 floor going all the way through it. Maybe they want to stagger, the floor plates like everyone likes to do. Or maybe you want to have like a space in between one of these volumes where you have kind of a higher floor-to-floor height. It's sort of in the center of the volume. I can assign mass floors to these, but they're going to behave a little bit differently based on how I've placed them. So again, I have separate volumes, and then I have this one that when I select it, it's kind of selecting all of them together. I'm going to go into an elevation real quick, and let's just do a recap on mass floors. I'm going to change my level 2 height. I'm just going to make it like 14 feet, which is a more realistic floor-to-floor height. And I'm going to add more datums all the way up so I can eventually get mass floors cutting through these towers. To do that, I'm going to select level 2, and I'm going to click on the array command. And the first thing it's asking me to do is select the kind of the base point. So I'm going to do level 1. I'm going to make my next snap up to level 2, so I'm getting the 14-foot dimension. And then if I zoom out a little bit, I get the number here that I can change. So right now it's set to 2. I could do 15. And that should array those floors all the way up. If you select those datums, you can also find that number again kind of hiding there. And I could change 15 to 16 or however many you need to go all the way up. Now what that allows me to do is add mass floors for everywhere there's a datum level. And again, this is how this is going to act a little bit differently. So I'm going to hit save here. Let's call that. To add a mass floor, you just select one mass. So if I select this one that's individual, I can click on mass floors and it brings up the dialog box for me to add however many floors I want. So in this case, I'm just going to select all of them, hit the checkbox, and click OK. So that one added mass floors to wherever that particular tower was. But let's say I go to the next tower over, I could change which ones or which levels actually get a floor. So if I go to mass floors, this time I'm going to alternate, let's say every other one, and click OK. And so that tower can have different floor-to-floor counts based on those datums than the other one that I selected. Now, why that's important is the one that I did everything where I modeled it all together, if I select that one and click mass floors, and again, I'll just do all of them to keep it quick. I can't differentiate between the different towers which one gets a mass floor, and it even did my, void elements in there as well. So that's why sometimes it might be better to model these things as these individual components. So again, those different families like we did in the conceptual mass environment and bring it in. And then also while you're in this environment, you could do mass 1 and mass 2 and so on. This way you can control or have a little bit more freedom in which gets a floor and which does not.
Can you show us how to add all those levels again?
Yeah, so I went into a north elevation. I'll do this at the top here, add some more. And all I did was I selected, let me ungroup those. I just selected one of the levels that were above, so level number 2. And if you click on array, once you've selected it, you have this array option. The first click is the base. Second is how far you want it to copy, so 14 feet in this particular case. And then when you kind of have to zoom out a little bit and find the number. There should be a number 2. You could change that box and change it to like a number 10, and that will copy it however many times you need. And then each time you select those array numbers, you should be able to find that dimension again, and I could change and manipulate the datums. Oops. And type in, some kind of integer. Looks like you have maximum between 2 and 20 in an array, so or 2 and 200. So by having those datums, then you're able to add all those mass floors. So another thing I'd like to do is flip back into our twisty tower. So if you can load up, yeah.
When we added new floors, it didn't show up under the floor plans for possible views. How do we like to do that?
Yep, so when you do an array, essentially Revit assumes that maybe you don't want a view for every single floor, but obviously if you're doing something for a presentation, you want to be able to work on each floor. What you want to do is be able to create those floor plans over here in the project browser. So to do that, you can click on View up here at the very top. And there's an option here called Plan Views. And when I click on that, I can choose Floor Plan. That will then bring up everything that's not associated with a part of the project browser. And then you could just select all of these if you wanted to. I'm not going to do all of them. Let me just do 3 through 7. Click OK, and it will start adding it to your project browser. Any other questions at the moment? You guys are still really doing a lot of massing and form finding? Okay. Good. So what I'd like to do is go back into the twisty tower family. And this time I'm going to do a save as, because we've already done this where we have a type 1 and a type 2 and type 3 family in it. I'm going to change this to a twisty tower as the name, and I'm going to do an underscore and call it offset facade. Basically, I'm just changing the name so that when I load it into the project, I don't overwrite all the other forms that I've already created. Everyone have your twisty tower back? So another thing that we can do in the masking environment is we can actually use this point element. This point element actually does a lot for us in this particular world. We can actually use this point. So right now the points that we have placed are actually driving geometry. So, everything was rotated around or referenced to that reference plane of that point. And wherever that point goes, we're going to change our form. This point can also act as a host on a particular surface. So I'm going to choose just one facade. It doesn't really matter. Just pick one. But I'm going to place a point on kind of the corner. Should be able to pick the line here. Might have to rotate around. But if I click on that, I should have that point placed on the corner. You see how when I select it, I've kind of got that point, and it also has a horizontal plane that's associated with it. I'm gonna place 2 more of these. So if you missed that one, I'm gonna place it on the other side. It looks kind of dark on that other side. So again, I'm gonna hit the point, and I'm gonna snap to the end or this line, and I'm gonna go ahead and do this 3 times. And I'm gonna do it on each side of that facade. So if you select each of those points once you've placed them, I'm going to hold in the control key to select them all. I'm going to, over to the left where it says show reference planes, it's currently set to when selected. I'm going to change that to always. This way I can always see those perpendicular planes to that form. Now I'm going to test something out real quick. If I go into my family types and change my tower, all of those points still move and kind of still are part of that particular form. So these points are now hosted to the form. What's important about that is they're also hosted based on a relative distance from the endpoint of this line. If you look at the tower, this would be kind of the start and the end of this particular line if you think of the edge as a particular line. If I click on one of these points, look to the left, there's this option here, or this parameter called normalized curve parameter. And it's not really important what that means, but all you need to know is that a normalized curve parameter is a decimal value between 0 and 1. 0 is going to be the start point, number 1 is going to be your end point. Every decimal in between is some kind of percentage in between. What that means is if I click on this particular point, and I'm going to change this to 0.75, that point is going to move so that it's always at, basically 3/4 of the way from the start point. Does that make sense? So it's going to be in a if you think of your fractions as decimals, and what that means is when I change my form, so if I go back to like a type 1 and click on that same point, it's still at 3/4 of the way. So what that allows you to do is specify a particular part of your form exactly where you always want some kind of reference plane, or what we're going to do here is an offset, peeled away kind of facade that everyone is kind of trying to do.
Wait, how did you switch between your
Tower types. If I go back into my family types dialog box, all I'm doing is selecting a new one and hitting apply.
Oh, okay.
So I'm going to set these points. So I've got 6 of them. The 2 at the bottom, I'm going to set that normalized curve parameter to 0.25. I'm going to do the middle one at 0.5. And let's do both the top ones at 0.75. Now what I'm doing is I'm using these as a host and a reference plane to show me what the surface normal is off of this particular twisty tower. Surface normal, for those of you that don't know, is basically any kind of, if you imagine a surface, it's whatever's directly perpendicular to that particular point where it occurs on the surface. So this point is showing me surface normal in that direction, and no matter how this twists, that point is always going to rotate to show me that normal direction. We need surface normal in order to do our offsets so that we can kind of come up with a new sort of offset facade here. I'm going to hit save since I have those working. I'm going to make 2 parameters. We're kind of adding on to our twisty tower now that we're doing this additional form. I'm going to add a parameter called, let's just call it O1 for offset. It's actually the letter O and 1. So that would be O1, and I'll do the other one as O2. One thing I want to mention before I move on is that when I click on these points, I can actually change the measurement type of where this point occurs. Right now it says normalized curve parameter. I can actually change it to a segment length. So I could actually give it an actual value. But I'm going to caution you on doing that, and that's because whatever value you put in there, so if I put in 10 feet, it's always going to be 10 feet from the end, which means sometimes that point, let's say I typed in 150 feet. Let's say my tower changes overall height to 75 feet. That point will no longer be hosted and is going to basically give you an error message because it's going to still want to find the 100-foot mark. So that's why I like to use the normalized curve parameter as an option, because it's always going to be kind of this percentage between 0 and 1. So just be cautious on that. So what I'm going to do is on...
Jeremy,
yes.
can I ask maybe a little bit, the normalized curve parameter, does it, I mean, I'm not familiar with it in Revit, but sometimes in Rhino when you get the U coordinates for the curve, you'll end up with spacing really far apart and really close together for the curvature. Does the normalized average it over the entire length of the curve?
Yeah, it's over the whole entire length of whatever the length of your line is, even if it's curving or...
So if I selected the non-normalized, that would be the proper parametric equation U value.
Right.
Okay.
Yep.
That helps me.
Okay.
I don't know if it helps you guys. It really helps me.
Yeah, so it doesn't matter what type of line it's on, it's always going to be 0.25 or whatever percentage along that path of the line.
If it's the normalized.
If it's the normalized,
Okay.
yep. So what I'm going to do is create a couple offsets, and then we're going to create another particular surface. Now, one thing that Revit doesn't have that Rhino has and does really well, Rhino does great with offset surfaces. You can create whatever form you want and then offset the surface. You can even get into Grasshopper and do all that, and you have all these different options. In Revit, I do have an offset option, so here is offset, but I can't select anything to really offset except for a line. So it doesn't do surfaces, so what I have to do is build my offset. And the way I'm going to do that is by creating a reference line. So if I go to create and reference, you see you've got an option here to make a model line or a reference line. And I'm also going to draw this line, but before I draw this, I'm going to use the placement plane, and I want to choose pick, and I'm going to pick the horizontal plane of one of those points. I'm then going to snap to the center of that point, and then I'm going to draw a line. You'll notice that when I kind of snap to the orthogonal, or I should be able to snap to the orthogonal, I want to draw a line that's 90 degrees. So you should be able to see 90. And I'm just going to draw it off into space somewhere. It doesn't matter where it is. But what we can do is I can click on that line once it's placed. And you'll notice you get a temporary dimension that shows up. And you also get this icon that is, it looks like a little dimension icon. If I click on the icon, it makes that into a real dimension. What's important about that is that's how we assign that dimension to be equal to, and we'll make the ones at the end equal to offset 1. Everyone see how I do it? I'm going to repeat this 5 more times, so you should be able to get it as I move along. So the next one, I'm going to move down. I'll hit reference line. I want to pick that particular reference plane. I'm going to snap to the center. I'm going to do a 90-degree line. Select that line, and then select the temporary dimension. The one in the middle, I'm actually going to make that equal to 0.2. Kind of give this a little bit of a bend later on. And then I'm going to go down to the end. Unfortunately, we have to do this each time. There's no kind of like copy to the next point, because we're always hosting or having to specify a work plane.
I feel like when I change my dimension, it's blocking to the center of the line rather than the origin point. Is that just because I'm not sure what I'm doing?
Let me check that. I'm actually going down the side of the wall. So this one's 0.1, middle's 0.2, and that's 0.1 again. I'm basically making it so I can get a different offset in the center. And I'm going to do that on both sides. So I'm going to click line, reference, keep doing this, pick. I'm going to pick that horizontal, and I'm just going to repeat this each time. It may seem a little bit tedious, but one thing that's to keep in mind is that these should rotate with each of our different towers that we create. So we should be able to always control these offsets as needed. So let me finish these up.
Is anyone having issues with their point not being normalized to the proper surface?
Yeah, if it's not, you mean it's
Like, we had an issue over here where it was the points, the normal of the point was associated with the wrong surface. Anyone else have that issue, or haven't run into it yet? Okay. Seems like if you just go from the surface to the edge, whichever surface you go to the edge from is the one that will normalize the point to.
Oh, I see what you mean. It was rotated.
It was normalizing to the other surface.
Yep.
Normalizing probably, I think that's the right word.
So would that mean that you would have to put a set of points down each edge twice for each surface that intersects that edge?
Yeah.
I think so.
Yeah, you would have to, and I think if you tab over, you see how right now it's a little easier to see on the light side. When I'm placing this point, you see how it's highlighting that surface? You can kind of see the blue highlighted edge. If I keep that highlighted, that should be placing it on that surface for the normalized curve to work, or the normalized surface to work. If not, I'll have to troubleshoot that a little bit later. So I got one more left to do here, and then we can make this little offset. Yeah. And sometimes you have to rotate around, and I wasn't paying attention on this last one, and I actually drew a model line. That's okay, because you can always click on it and then also change it back to a reference. And this one is 01. So I've got all of these placed. I'm going to make my, I'm going to change my parameter here for 01 and 02. I'm going to make it a little bit more drastic for now, just so I can see what's happening. I'm going to do a 20 foot for 02. Let's do a 15 foot for 01. So we should see all these lines coming out of the surface. Now, when you're making these kind of offsets, because it takes a lot of time to set it up, I would only do your extreme condition. So, right now when you look at this, you're thinking probably, oh, this looks like great supports, coming off your facade, and I want to show every single support. If you do that, you're going to take forever doing that. And there's other ways that we can accomplish that in the future. But you really want to concentrate on what's going to make the form of your particular surface. So my extremes are the endpoints and then the midpoint, because I want a different kind of curvature at the mid. Obviously, if I just wanted to concentrate on the endpoints, I would just do the ends, and I wouldn't have so many points. So the last component here to make this work is I'm going to make we could actually do a spline here. It's actually easier. I'm going to add a point. I'm going to use these point elements one more time. And if we host those to all of those reference lines, and again, we can, so I'm taking a point and hosting them. I can then select each of them and make them move to the endpoint by changing their normalized curve parameter to 1. What I'm using those points for is eventually there's going to be a spline through points, and then we can loft those two wireframes together and make our surface. Everyone see what I did there? All I did was I took another point and I placed them on this reference line, and then afterwards I took each of the points and I just changed the normalized curve parameter to 1, and it moved it out to the end. That makes sure that those points always stay on that reference line, because the reference line is controlling your offset. And before we move on, we should test that things are working. So if I change my tower type, I should have, my offsets are a little bit smaller, so I'll do, and I did 20 foot for 02, and then 01 is like 15 foot, just to be drastic at the moment. So then the next step would be to generate our wireframe. I'm going to go up the side, and I'm selecting those 3 points that are at the end, and there's that option there to do a spline through points. We can also turn that into a reference line just to make sure it stays, it doesn't go away. And I'm going to do the same thing on the other side. Spline through points, and also make that a reference line.
How do you make it a reference line? Just click on the line.
Yeah, you can just click on the line, and there's that little option over here, is reference line. So I didn't test this out. I hope it works. I'm going to hit both of those. I'm going to hold in the control key, and I should be able to hit create form, solid form, and I now have a kind of a sheet of paper basically that's out there. Now when we're in this environment, what we're really doing is defining a general shape and a general form that we can eventually divide and then apply some more tectonic structure to. But we don't need to worry about thickness. We don't need to worry about other components at the moment. We just want to use this as a formed surface that we can eventually sort of cut up and apply other components to. So right now I've got that sheet of paper, and I should be able to, again, change our tower types, and everything should always move. And you should also be able to change your offsets, so I could be a little more drastic with that middle piece, and do whatever you want there. So again, for those of you that were doing your peeling away at the corners and whatever else was happening, this would be a strategy I would suggest, because it's always going to be tied to your form. And no matter what you do with this tower, if you start changing your particular form, your offset surface is going to move with it at all times, and you don't have something disjointed from one form to the other. So I'm actually going to keep it like that for that tower. It's a little extreme, but for each tower type, I'm going to add in some dimensions for my offset. So does everyone have those working? And then what you could do eventually is, if you decided that you wanted your form to be a lot longer, all you have to do is go back to those original points, and you could change, again, those normalized curve parameters. I could even make them, they don't have to be the same across the surface. Now, there are always going to be those particular normalized curve parameters on every single tower type. But the one thing that you could do if you wanted to take another step forward, and I'm not going to because it will take too long, but I could actually select this point, and you see where it says normalized curve parameter. It has a little button next to it. I could actually make that its own parameter as long as it's a number. So if I could just do this for this one point for now, just to make an example. I'm going to call this top n for now. But my type of parameter would be a number. And I'm going to change this to 0.95. And I could actually set that point equal to a normalized curve parameter that I can eventually control. What that means is, for type 1 tower, it could be up at 0.95. But if I go to type 2, maybe I want that point to slide down. So you could actually make, you could really take this another step forward and get a little more extreme by also controlling all of those points for each of your different tower types. So that's all I'm going to do with the form finding for a second. I want to get into these curtain panel pattern-based families, kind of do a quick little tutorial on that, and then also adaptive components. Because there's some pretty cool things that we can do with that. Any other questions about massing at the moment, besides kind of what we've done? Is this helpful, hopefully, for what you guys are doing? Okay.
I have a quick question.
Yes.
And I don't know if this is an easy one or not. If it's not, maybe it doesn't matter. But the rectangle that is the top of the tower.
Yes.
When we can rotate that around the z-axis.
Mm-hmm.
Okay, that's how the rotation works. Is it possible to change and tilt it about the y or the x-axis?
It is possible, but unfortunately, it's either one or the other.
Okay.
So if you notice that when I placed that point, what we did it in plan, right? We did it in a plan view. If you were to go into an elevation view and actually place a point, so I'll just place this one off to the side.
Okay.
This will now rotate about whatever axis the north elevation is at. So I'm going to turn on. Let me turn on the reference planes. So now that point, because I drew an elevation and I rotate, you can see how it rotates around the x or the y instead of the z.
Yeah.
But it's only going to be one or the other, unfortunately.
Okay, you can't change that later on the fly or whatever.
No.
Okay.
So yeah, if you wanted the top to sort of do something different, kind of rotate up and so on, you would probably have to think about at the very beginning what you wanted to rotate eventually. The other option would be, let's say you've already done all of this and you wanted to start to rotate or have something to kind of tilt up. This is where these points again would come in. I would probably host a couple more points and this time make it. Let's see if I can. So you see I can then draw my offset And I could actually draw another line there and then start to loft it together and make kind of a top cap. So you could probably do that, and then that way you could get a rotation in plan, and then you could also change the offset and you'd get a different rotation that way. So that'd probably be an easier strategy.
Could you, can you host a point to a point so you can have like a universal joint?
You can host the point to the reference plane of another point.
Right, so you could have, that one could be one way and then the other one could be the other way.
Yep.
I'm just,
Yep.
just playing out scenarios.
Yeah, you can, as long as, the nice thing about the reference point is because they have those 3 reference planes associated with them, as long as before you place something onto it, you always pick one of those reference planes, you can host whatever you want to it. So it could be another point, and then you could...
That could accomplish that task.
Yeah, you could probably start to do that as well. So you could definitely play around with those as you need to. Now, one thing I want to do...
Let me just help you.
Yeah.
Guys, because we started late with the lecture, Jeremy has agreed to stay till 6:30. I know that doesn't mean that all of you can necessarily do that if you have other classes, but hopefully, I think when I sent the message out, I kind of forewarned you for that. So if you do have a conflict, let Jefferson know on the way out, and otherwise we're planning to stay till 6:30.
Yep, that's what I was planning on, so we're going to go towards that point. Okay, so now that we have these forms, one thing that we can do is I'm going to play around with this facade, the offset facade that we just created. If you select that particular facade, and we can do this on any mass, so I could actually, tab over and select another face, over here to the, that's part of my tower. But notice what happens when you select a mass. You get this little option up here called Divide Surface. And this is one of the most, I think, interesting parts about the conceptual design environment, because when you click on Divide Surface, it instantly makes a mesh that's over your entire form. It doesn't matter what the form is. And you can kind of divide this mesh into increments along your U grid and a V grid. For those of you that are familiar in Rhino, if you're looking in plan, let's say I'm looking in a plan view, we all know that sort of your left and right is your x-axis, right? And up and down is your y. And then going towards you in the plan view is your z-axis. Once we start working with surfaces that are not part of the orthogonal plane, and it doesn't matter, the surface could be orthogonal, essentially on the surface you have a U grid and a V grid, and when you look at it, you can sort of look at your options bar. If you have your divided surface highlighted, your U grid is all the horizontals going up that surface, depending on how you're looking at it. Your V grid is all of the verticals, so that's like your Y on your surface, and then your U grid is like the X on the surface. And then, of course, surface normal is towards you when you're looking at that particular component. What that means is when I select that divided surface, I can change the divisions. So let's say I want, I've got 12, by default it's always going to be 12 and 12. I'm going to change this maybe to 12 and 8. 12 and, well, let's play around with it a little bit. So actually it looks like it's kind of rotated actually. So sometimes you have to play around with, I'm not sure when it picks. Probably has to do with the way you created the form. So actually in my case, my U grid is actually dividing up in the vertical in this case. So anyway, just play around with the numbers. I'm going to divide this up a little bit. I'm going to do my other one, since it's going around a drastic curve, I'm going to create a couple more, more meshed items here. Now, we can click on this divided surface. So if I click on it, to the left you have an option to change this to a different grid type. So I've got arrows, hexagon, octagons, rectangles, checker patterns, rhomboids, triangles, and zigzags, and so on. All of these are pre-programmed in Revit, so we can't change them. We have to just use one of these particular grid patterns. But this is important when it comes into what we're going to be doing next. For right now, we're just going to deal with the rectangle. But for all of you that always do a like a honeycomb structure, you instantly have it. I don't know how many. I think I taught a whole class on Grasshopper just how to make a honeycomb structure, and it was this huge long script. And here in Revit, you can just click on it right here. You got honeycomb. You're good to go. So yes.
If you went back and changed those offset 1 and 2, would you have to readjust your grid numbers?
Right. So again, to take this to another level, so right now I've done all of these U and V grids that are associated with this particular surface, and that's actually a good question, is that when I change my particular tower type, so when I go to Tower 1, I still have the same exact number of divisions. Actually, no, it actually changed it. So it's doing fixed number. That's interesting.
I think that's what you had it done.
Yeah. So it seemed like it changed it. But what I was going to say is, as I get smaller, doesn't like type 3. What I was going to mention is when you click on that surface, notice to the left you can change. Again, you have all these buttons associated with all of those surfaces. You could actually make a parameter for the number of V and U grids for that surface. So for each time you change it to a type 1 tower type or a type 2, you could actually specify what the division is later on, which is actually probably pretty useful if you're going to be stretching things on, up and down. So why this grid is important is that this grid starts to work with other parts of the conceptual design environment within Revit. And the conceptual design environment, if we go to View, let's go back to View, User Interface in our recent files. I'm going to open up a new family. So we go to New, and we want to pick, it always wants you to pick like a new particular template. But the conceptual design environment, these are the families that will work within this modeling environment that we're in. Number 1 is this one here called Curtain Panel Pattern-Based Family. The other one is called Generic Model Adaptive. And then, of course, you have your conceptual mass and your mass. Those 3 are the only ones that work together. If you try to bring in a window, for instance, or a door into this environment, it's not going to allow you to do it. So just keep that in mind. This is where modeling the form, it's really about the overall form, and it's also about dividing up the surface and creating tectonic facade structures. It's really kind of the limits of this particular environment. It's also for creating your mass floors and other ways of hosting geometry. But you're not going to be able to make spaces like a room and put doors and windows. Just keep that in mind. So what I want to do is go to the new family, and I want to open up a curtain panel pattern-based family, and I'm going to click Open. Now when you look at this, you'll notice there's a grid, and there's also 4 points that are hosted, and there's also a set of reference lines that go around it. If I select the grid and look to the left, you notice I can change the grid to all of those different options that we had on the divided surface. That's how they make the connection between the divided surface and whatever component you're making. What's important about that is before I make a component, I have to understand or know or pre-plan what my underlying grid is going to be. So if I'm going to start off with a rectangle, I can't later on change it to this particular pattern, your honeycomb structure. So we want to make sure you plan what you're dividing up before you start actually doing this modeling, these next couple steps. To keep it simple, I'm just going to keep it as a rectangle, and I'll let you experiment on your own with these other forms. But notice what happens when I change all of these to different different grids. I get more and more points based on the different configurations. That'll come in important a little bit later. But I'm going to change that back to rectangle, and let's just do something real simple here real quick. So to model in this environment, basically you're thinking about what is the one component that you want to eventually repeat over and over again across a surface. This is kind of like a copy command or array command. You kind of want to isolate. If you had to draw your component on a piece of graph paper, this is what you're doing. And so I'm just going to do a quick little die-grid, which is basically a rectangle or some kind of square with a diagonal through it, and then we'll put some solid geometry to it. So to do that, I'm going to select point number 4 and point number 2, and I'm going to use the spline through points to make a straight line. And in this environment, everything we do, we want to make it into a reference line. Now, one thing to keep in mind too is that your form is always going to stretch depending on how you divided up your surface into your U and V grid. So it's not always going to be the same width and same height. So you have to understand that sometimes this could be an elongated triangle or elongated rectangle in one direction or the other, depending on how you set everything up. But to make solid geometry, all we need to do is eventually create a sweep. And to create a sweep in this environment, we need another hosted point. These point elements we're going to use all the time. I'm going to take one point and I'm going to host it on the outside part of the perimeter, and I'm also going to host one here in the middle on that diagonal. If I select those points, I'm going to do a show reference planes and set that to always, and there we've got again a perpendicular reference plane to that point or to that reference line. If you're familiar with the follow me command in SketchUp or the sweep command in Rhino, you know that you have to have a path, and then you have to have some kind of perpendicular drawing surface that you draw kind of what you imagine the section cut of your profile would be, or your solid geometry, and that's what gets swept across the particular path. This will make sense here in a minute. So what I'm going to do is I need to draw on each of these reference planes. I'm going to draw, just to keep it simple, let's just do a circle. We'll kind of make this pipe structure. So I'm going to click on circle. And then before I draw, I want to pick my placement plane. I'm going to first pick that one that's on the perimeter. I'm now going to snap to the center of that point and just draw a big circle. It doesn't matter what the size is. We'll adjust it in a minute. I'm going to do that on both of these. I'm also going to change that circle into a reference line. So again, if you missed that, I'm going to go to Create, Circle. I'm going to go to Pick, and I'm going to pick this other reference plane. I'm going to snap to the center of that point. And then I'm also going to make that into a little reference line. Now, because I don't really know the overall scale of wherever I'm going to be placing this, I want to make these circles, change my form parametrically. And all I'm going to do real quick is I'm going to take each circle and I'm going to choose that little icon that's associated with the dimension that shows up. And then we can make a parameter called R for radius. I'm going to add a R, and I'm also going to change this to, let's just make it like 6 inches. Seems to be maybe a better scale. And then we can select both of these dimensions and we'll make that equal to R. What that allows us to do is later on when it's placed to the divided surface, if we decide 6 inches isn't the right scale, we can just edit this one time and change to 6 inches to 3 inches or whatever we need.
You got a question?
Yes.
We've set another length H, and we want the radius to be tied to H when we set it as a proportion of H.
So you want like 2 radii?
Yeah, like if you want, R1 is always twice R2.
Yeah. So if you had 2 radius dimensions, one thing that I haven't gotten into is you'll notice that in this family types parameter dialog box, remember I said this is kind of like an Excel spreadsheet. There's this option here to enter in formulas. So if you are familiar with just any kind of mathematical expression, I could actually make another parameter here called R2, And I want to make sure those are together, just R and 2, no space. In the formula box, I could actually do a formula called R times 2, and that would always make the second radii, 2 times whatever the first one was. Which means I can only edit, R1, but as I change that, obviously, to 4 inches, my R2 will change to 8, and then I could, let's say, make this perimeter one, I'll make that equal to R2. So what's nice about that, you can actually make things more computational. You can actually make things drive one another. The key to working in formulas and parameters is that, remember I said you could name your parameters anything that you want? Just be careful if you're going to start using them in formulas that you don't name them with mathematical expressions. So a lot of people like to name things where I could do, let's say, R-4 as my parameter name. When I enter R-4 into the formula box, it thinks it's looking for parameter R minus 4. So avoid mathematical, symbols. And then also, if you're going to name things with numbers, always make sure there's no space. Because if it's a space, it'll also start thinking that you're trying to do something with the number 2 instead of making that part of the name of the parameter. So yeah, there's a lot of pretty neat options there. But all we have to do in order to make a sweep is select your profile. So I'm going to select that circle. Then I'm going to hover over and I'm going to hold in the control key and select my path. I'm also going to just go all the way around and select the rest of it. Once I do that, I can click Create Form, and it'll make basically a sweep all the way around that perimeter. I have to do the same thing in the middle. So again, if you missed that, I selected it doesn't matter the order really, you can just select both of these items, but I need a profile and the path, and then choose Create Form, and I've got that as an option. Now I want to save this because I want to be able to name it and apply it to my divided surface. Let's just call this diagrid for now.
So that's a family.
Yeah, all of these will always be a family. And now I can hit save, and I'm going to load this into the project, and I want to load it into my twisty tower offset facade family. And let's look at it in 3D because it looks better. Now to apply this component to our divided surface, all we have to do, and this will take a little bit of time, you'll notice a little green progress bar will show up in the bottom left corner, but I select my divided surface, and now when I choose my different grid options, notice when I scroll down under rectangle, I can select diagrid. Now it's going to take a minute to generate because it has to place one of these components on every little part of my divided surface. And so actually for this example, I should have made bigger dimensions here, and it didn't like something. Let me try. I'm going to close some of my windows here. Let me go back a second. Sometimes you will get, can't make form or something like that, or try to delete the type. I just want to test. I'm going to change my division here. It's not always perfect, but you will, depending on how things are divided up. Let's see what this does. Really? This never happens when I do the example the night before. When I do it in class, there's an error. Let's see. Let me try a different surface real quick. It could be my curvature may be a little extreme, and there might be something in my curtain panel here that's not working.
Mine succeeded on 2 of my squares when I make my angle less extreme.
Can't make type rectangle diagram. So something in the, there we go. Something with my middle diagonal was causing an error. So sometimes
How'd you fix it?
I deleted it. I deleted the center portion, and that took care of it. Let's see. I think what was happening is, for some reason, my circle, I think it was twisting in the middle. Let's try this as a fix real quick. I'm not going to troubleshoot this too much, but I'm going to make another point and set that to always. I'll create another circle. What I'm going to do is, I think this diagonal is somehow twisting. I'm going to force it to hopefully just extrude. So I'm going to pick each of these circles and not the rail. Oh, these will be a reference. And since these are on a line, I can change them to 0 and 1. There we go. So did everyone see what I did there? I basically went back. I was getting an error message, and that's why I couldn't make the form, and everyone was probably getting that. For some reason, sometimes when you do these sweeps, it likes to rotate that point, and I think it was rotating and doing things that it couldn't actually form. So I'm going to step back here, and if you click on your center diagonal, you can click on dissolve. If you click on dissolve, that takes away everything that made up that solid. What I'm going to do is actually place 2 points on this diagonal. I've actually never had to do this, but I'm going to select both of those points and make these show their reference planes set to always. And I'm going to make a circle profile on each of those planes. So I'm doing the same steps where I did a circle, but I'm going to do one on each of those placement planes. Basically what I'm doing is making the endpoints of that center digrid, or that diagonal. And I'm also going to make those equal to the R1 radius. So now instead of doing the sweep, because they're on a line, and they're always going to be, no matter where this line goes, I'm going to select each of the end profiles and just choose create form. What this does then, remember these points are hosted on that line. I can use my normalized curve parameter, and if I want to move it to the end, so I can type in 0. You might get an identical points issue, but that's fine. And the other one would be 1, and would take it to the end. So now when I save that, that seemed to solve my problem. And when I load that back into the project, you always want to overwrite the existing, and I usually do the version and its parameter values, because that changes, whatever edits you made in the family environment. But you can see now it actually should work on any surface that I place it on. I'm 99.9% sure.
When I place it, it doesn't look like what I drew in the other
Area.
So like my angles are crazy.
So that's basically the kind of the general construct with working with those curtain panel pattern-based families. Is whatever you can imagine you can draw within that grid. So within that little rectangle, and everything. A lot of people sometimes get error messages, or you get things floating off into space. You always want to make sure that when you're in this environment, that whenever you draw, I always select those endpoints. Everything always has to be hosted to those endpoints, and use the spline through points. Let's see. So if I pick and go back to a wireframe, I want to pick each of those endpoints, and if you use spline through points as your draw mechanism, you'll always know that those are locked to those endpoints. So no matter where those points go, that line is going to move with it. And then as you draw different parts and pieces, you want to make sure that you can use those reference lines as host points. Now, right now, we've done a sweep. So we did this kind of pipe structure that went around. Another method of working in this environment, and what I'm going to do is, let's select everything and click our filter. I'm going to click on check none, and I just want to show the reference lines, reference points, adaptive points. We'll click OK. Whoops. Do that again. Select everything, hit filter. I basically want to select, actually we want to select other, and I'm going to hide those. That's basically the solid geometry. So if you go to your sunglasses down at the bottom and hit hide element, and the reason I'm doing that is I want to be able to select a couple things to make some solid geometry. Right now we did the sweep. You can also do extrusions off of this particular plane. So if you were to select this diagonal reference line and then some of the perimeter components, I'm just going to select those part of the triangles. If you hit create form, solid form, notice down at the bottom, do that again. When I hit create form, I get this little icon down here. One looks like it's extruding the element, the other one looks like a flat piece of paper. I usually want some kind of thickness, so if you go ahead and click that one, it'll extrude it, and it'll be some kind of extreme value. But if you look to the left, there's a positive and a negative offset. That means it's going to either extrude positive up, and then down is going to be negative. I'm just going to type in, let's do 2 inches for each, so that we have this solid geometry extruding up and down about that center point. If I go back to my sunglasses and hit reset temporary, now you've kind of got this solid geometry that's part of that digrid, and then you can load that back into your form. For each change that you do, you can just override it, and it will then update. So you have basically 2 drawing options. You can extrude and you can sweep any kind of profile. And that sweep profile can be anything you want it to be, just as long as you can imagine it in section that's perpendicular to that reference plane. And so now you can get some other designs that's part of that. Now I can take this one step further, and I'm just going to do this quickly, is while you're in this environment, I could select that solid. Actually, I'm going to back up. I just hit Control Z, and this time instead of doing an extrusion, I'm going to select the one that looks like a piece of paper. I can take this even further by selecting that particular surface and divide that up, and you could apply more, components to that, and then, embed that within your other component. I'd advise you not to divide it too much because, you can really get some pretty detailed, intricate components that start to take up a lot of memory. But, if I wanted to divide this up a little bit more, instead of having, maybe I only want to do 3 and 3, I could use this as a kind of base underlay to start to draw other things on top of it. I can select these surfaces, and this is something to note and something that's going to segue into our adaptive component segment, is if you go to surface representation after you've selected your divided element, there's a little down arrow that's up there. You can click on this option here where you can turn on the nodes. And what that does is it makes a point at each of the grid intersections of this particular surface that you could then snap to. So I could then draw using 3D snapping. And I could draw something that's just floating, or I could make some kind of other shape here. But you could start to use that as an underlaying grid that you could snap to different points and then make other different designs within your solid surface. So I could take that, create a form. So you could divide that up as much as you want, and come up with other components. Obviously, I would want to do something else with that, but you could load that into your project. And no matter where this goes, you should always have that little trapezoid in there instead of that solid surface. It'll take a minute to generate because it's got to recalculate all of those. So the next thing that I want to show you is there's that curtain panel pattern-based family, so it's always based on some kind of underlying grid. And there's another thing we can do, which is called adaptive components. And adaptive components is where you can actually make your own pattern and then place it either on a grid that has nodes associated with it, or you could use it as basically a kit of parts that you could start to draw. I'm going to make this pretty simple actually by going into our view. Let's go to user interface, recent files. And under families, I'm going to open up, instead of a curtain panel pattern-based family, I'm going to go to generic model adaptive. This is the other component that we can use within the conceptual design environment.
What did you pick? I'm sorry.
Generic model adaptive. Now in this one, you just basically have kind of this open, free-form place to draw. There's no underlying grid that's associated with it. But what we can do is draw a point. And I'm just going to make a line here. I'm going to draw one point and another point. Once you draw points, we can actually select those, and we have this option up here called Make Adaptive. So you can actually turn those into adaptive points, and you notice they start to look like the curtain panel family where we've got point number 1 and 2, and obviously if we have more points, they'll be consecutively numbered.
Did you snap those to the line?
No, I just it doesn't matter where they get placed, because these are adaptive. They're going to move no matter where you end up placing them, within the next part of the project. So they're free floating. So I'm going to select point 1 and point 2, and I want to do that spline through points option. So I know that the line is going to be snapping to the endpoints, and then I'm going to also turn that into a reference line. I think I'll just move these off to the side so it doesn't look like they're snapping to anything. And I also want to make sure that that's a reference line. And I'm going to make a pipe structure. So again, just like we just did with that middle die grid, I'm going to quickly place 2 points on that line. And I can draw those circles, and we'll go ahead and go from there. But basically what I'm doing is I'm making this pipe that I can actually draw anywhere. So it'll also be like, instead of drawing a line, I'm actually drawing with pipes. So you could actually make your own kind of kiddo parts that you could eventually snap to things, which comes in ideal for structural components and so on. So I'm going to go to Create, Circle, Pick. That one. I'll do another pick. I'm turning both of those into reference circles. And I also want the dimensions, just so we can size them later. Made a parameter called R. I'll just call it 6 inches for now. And then I'm assigning each of these radii dimensions to that. So just like we did in the middle, I'm going to select each of those end profiles and perform a solid form, and then I can move these points to the end. So that one's closer to 1, this other one's closer to 0. Normalized curve parameter. And basically what I've done here is I just made a solid extrusion that's going to be controlled by 0.1 and 0.2. I'm going to save this. I'll just call it adaptive pipe.
Did you put them at 0 and 1?
Yeah. And now I'm going to actually load this into our twisty tower again. I'm going to, let's see what I want to do. It's actually off to the side. Let's do another thing here. I'm going to draw just a, oops, I'm on that. Here we go. Let's go to the bottom. I'm going to draw just a spline through points. It's not the best way to do these, but I'm going to make a kind of little squiggle line, and I'm going to go up to the top view. I'm going to make another squiggle line and do something different, just so I have a... And all I'm doing is making these two profiles that I'm going to loft together. And I'm just doing this as another form. I could have done this on the tower if I wanted to. But once I have some kind of geometry or form, I can actually divide that form, and then I can use the nodes option. So I'm going to select that form, hit divide, and then I'm going to turn on my surface representation and click on nodes. This gives me the ability to snap sort of this adaptive component basically to this grid. I'm going to switch back into my adaptive pipe and load that in. I don't know if I did that already. And all I'm doing is I'm going to hit create component, and here's my adaptive pipe. It's basically going to be drawing, 0.1 and 0.2. So I'm going to snap to this point, and then I'm going to go to the next one, and that's all I'm going to do. But now that it's snapped to this grid, I can actually select that adaptive component, and there is no array command that we can use in this environment, but if you look to the left, there's this option here called repeat. I can actually click on that, and it's going to remember what I just snapped to, and it's going to repeat this adaptive component across all the nodes of this surface. So you can start to imagine, depending on how I snap to things, I should be able to do another one here. Let me hit create component and go kind of diagonal. You have to make sure that you're snapping to the points. You sometimes have to, when you have solid geometry, go into like a wireframe view. Nope, that didn't work. Create component. Go back. And again, I should be able to repeat this one.
The problem I've had in the past with this one is if you do like more than just 2 points, like a 10-point object,
Mhm.
and you start to go along a curve, this starts to flatten along, like it doesn't keep its axis. It starts to like flatten along the Z. Is there a way around that?
Yeah, so actually what we just did in my BIMethods class last night was we created this structure, and let me, probably easier to look at it. So we actually been working with a better way to make a curve. So we've been actually using these Bezier curves that we made. But this curved arch is actually made up of one adaptive component that's actually made up of 4 points. And so all we did was you actually have the 4 points, and each point had a hosted profile. So I just basically, we had this like tube steel section that was hosted at each plane of those points, and then when we snapped those to the grid, it actually stayed perpendicular the whole time. So yeah, the one thing you have to be careful is when you start to place more than 1 point, you have to be careful of how your profiles eventually twist. And what we've been doing, and I can show you a quick little method, but I'm going to click on this profile, and instead of drawing a profile in every single plane like I've been doing with the circle, a shortcut to that is you can actually, in a generic model adaptive family, is all we did was make a 2D profile that was parametric, kind of like we did in the last class with that rectangle. And this 2D profile is getting loaded in to another adaptive component that's getting hosted to all those points. And I can kind of give you a link to those videos if you want to go that far. But that makes it so you don't have to keep making a profile on every single point every time you want to, add, 4 points or 5 points or 6 points. You already have one and you just place it. So it actually works out a lot better. Yes?
My pipe is of a fixed length and doesn't have the beginning and end point as the 2 node points that I picked.
The fixed length. Let's see. So that's kind of like a quick introduction to that modeling environment. One thing, let me close a couple windows here, is you can start to imagine how you can get a lot of detail on very complex forms by imagining ways of dividing up the surface and either using curtain panels to apply it to it, or you could start using adaptive components. And adaptive components are nice because they're real free form and they're not always tied to a grid. So for instance, we just made kind of that pipe structure, and I applied it to a grid and then repeated it over and over again. But you could actually go back in. Let me go to the twisty tower. I'm going to just put another point over here. And I could actually kind of use this as more like a column structure or something like that. I have a lot more freedom because it doesn't always have to be tied to something. I could actually hit create component, and if I wanted to, just off into space, I could draw however long I wanted that pipe to be. So if you were trying to connect a particular surface to something, you could just sit there and draw from one point to the other. And if you imagine kind of these kiddo parts where it's either kind of like this pipe structure, or you could have like a tube steel, you could just sit there and draw all day long, and you're just drawing with sticks basically, and then you don't have to keep modeling those profiles over and over again. The other thing you could do is, for instance, I'm snapping to this one point, and then, not saying you would do this, but I could snap to one part of a node on a divided surface, and when I repeat this, it's going to go from this point to all of the other nodes all throughout. So it's going to get pretty crazy here, but you could have these other options of creating some kind of structure structural component, obviously I could have more points and those type of things and get a lot more detail and so forth. So obviously that's pretty crazy, but it works. So that what's nice about the, basically this is new in Revit, I think it came out in 2013, is that repeat command. Before that, if you were doing this with Revit 2012 or before that, you had to individually place each adaptive component if you wanted to make something like this. So it's kind of nice that they actually have that in there now. So you have a lot of freedom and a lot more play. We're kind of at the end of the workshop, but I wanted to go over a lot of what this basically conceptual design environment can do for you. I can give you links to other videos because basically in my building information modeling class, we go into this into kind of the nth degree. We're actually using Dynamo right now, which is a similar Grasshopper plugin that's controlling some randomization and all this, but not saying you'd go that far. But there's some other videos out there for you to watch. I told you I was going to get into talking about how to set up drawings and things like that. I can either send a video link to that, or how do you want me to kind of proceed to that? Okay. I have a couple of videos that will do some exterior rendering tutorials based on, do you guys have a site that you're working with yet? Like a topography or? Okay, so I actually have a tutorial where you place these kind of components onto a topography and then do an exterior rendering. So that would probably be a good tutorial for you. It talks a little bit about materials. And then the other thing would be talking about drawings, how to do sections and plans and put them on a sheet and then hit print, basically, to a PDF. So I don't want to go past 6:30, so I know we're kind of late.
Printing plans and sections would be very helpful.
Okay.
Definitely.
Just quickly, is the only way that you could get this repeat command to work where you're skipping nodes potentially is through Dynamo?
Like if you wanted to skip every other node or something like that, yeah, it'd have to be through Dynamo. Or you could, what I've done before is you cheat the system. You make two overlapping surfaces and divide the grid differently. Like you can offset the grid. That's one thing I didn't mention real quick, is when you've got these gridded components, like your divided surface, if you look down at the bottom or at your U grid and your V grid layout, you can actually rotate the grid. You can also offset it. So for instance, if I had two overlapping surfaces, I could divide them the same, but make one of them offset, so that it happens in between. And that's basically exactly what we're doing, with that other form in this Dubai metro station that we're kind of building.
My last question is, so we're working in partners, so we're both going to end up working in the same file.
Mm-hmm.
Do we need to, how do we package all of these different family files and things like that to make sure that we're working off the same stuff?
Right. So if you're working in groups, actually the nice thing about the family environment is, obviously everyone could have their own family that they're working on, or more than one family or so on. Eventually all those families need to get loaded into one file, so that's going to be your project environment. And when it's loaded into that file, it's as long as it shows up in the project browser, it's embedded within that file. So if you gave that project file to somebody, it's going to have all those families in it. So you don't have to worry about linked files and copying all those families over and over again to somebody else. So that's how you would package it, is make sure they're all loaded into the project environment. And you need everything in the project environment in order to do renderings and also to do the drawings. So that's the only environment that will allow you to do those functions. Whereas when I'm in the conceptual mass, I don't have an option here to create a drawing sheet or any kind of other view such as a 3D rendering. So that'd be
the only way we could sync that we're working within the same project on the network, or can we even do that on this network?
Yeah, so you're talking about everyone working in the same file. That gets a little tricky, and we did that with the Solar Decathlon group, and that still got kind of tricky because of the security issue, the security settings of all these computers. In the office, the way that we typically work, because on a large project, you're not just going to be one person on a 50,000 square foot project, everyone works in one model. It's called a central model that's saved onto a server somewhere. And then basically everyone is basically checking out a local copy. And there's this little option at the top that, when you hit save, you can actually save back to what it's called central. And so when you make changes, it goes back and syncs up to the main model. So there's ways of, everyone working in the same model at the same time by, sort of doing that. But unfortunately, you guys won't be able to do that. Really.
Does the Autodesk cloud service at 360 or whatever, would that allow them to do that?
I'll check into that because the students and faculty have free access to the cloud.
Right.
And I know one of their settings is for professional is like the cloud server,
Right.
where you could like host a model up there.
I think that.
So I'll check to see if it's available, because that would be the only other way to really do it.
Right. No, I don't know. That seemed to me to be the way to answer that question was through the Autodesk Cloud Services, through you guys. However, again, it may be the fact that you're going through so many firewalls here at school to get to that, it may either slow it down or render it practically useless. But it could work really well.
Yeah, and the thing about working on it's called work sharing is once you set that up. But you really have to make sure your connection to that main file, everyone has a good connection, because if I'm on like a dial-up modem trying to do something,
You guys know what dial-up is?
yeah, yeah, I'm dating myself, but I was even before then. But yeah, if I was on a very slow connection, essentially what would happen is I could possibly be changing something that you've already changed, and then it will lose the sync, and you run into a lot of issues.
So like dial-up or sitting in studio, pretty equivalent.
Right.
Could be. And the wireless is pretty good around here. I don't know about in studio, but
So you'll send the links to Jefferson and I, and we will upload them for the video and some of the other tutorials.
yeah, what I'll do is how I did the last one where I had the website you could go to. Off to the right, I'll put a series of links that would link to the other videos, so that you guys would be able to access it.
Okay.
But I'll send it to you and Jefferson, and you can forward on.
Yeah, thank you so much.
Okay.
I have a question.
Yeah.